Hello everyone. Let's get started with today's session about lists. So in the last session, we discussed something about Python data types, wherein we observed one of the complex data type was list. So in today's session, we will cover what we all can do with lists. So now we have a notebook file wherein I'm going to start typing the code, and on the fly we can see what all we can do with the list. So what you see on screen is a simple list where we have a couple of fruits as an elements. Okay, as you remember, like the list starts and ends with a square bracket. If you also remember, if we can identify the type of variable by using type command. So I say my list, type of my list, and it says it is a list. 1 minute. Yeah. So it says it is a list. So if we want to identify what is the length of list, we use something called as len, len, and then we pass our variable my list, and it says the length of the list is 4. So if you notice, there are 4 elements: apple, mango, kiwi, and dragon fruit. If we want to get the first element of the list, we can use index by calling out the index value. In Python, the index value starts at 0. So if you want to get the first element, we have to use something like this. My list of 0 would give uh, apple. So whenever you want to call out an element of within a list, you always use a square bracket. So within the square bracket, you pass the index. Say my apple, if you notice, is the first element. So the index of the first element will be 0. Similarly, because this my list has got 4 elements and the length of list is 4, the last element index would be 3. So in this case, my list, the last element is 3. So you notice the last element is dragon fruit. And just in case if you give any index which is beyond 3, it would throw out an error. So this is how it throws an error saying list index is out of range. So the other thing is like we can modify a given list. So what we call that as mutable list. So if you want to see mutable value, so we have my list here. I can say something like insert, and I will specify the index, and I'll say green apple, right? And then we can print my list one more time and see that the green apple is present in the last value. So we can specify whichever index that we want to insert an element, and then we pass the element value. So in this case, the element value is green apple and the index is 4. If you notice, we could also give uh, index value here, which is beyond 4. So in this case, if you like, let us see the length of, so I say length of, sorry, length of my list. The length of my list is 5. So it means that the last index value is 4. Now what I would do is my list dot insert. As you notice, last index value is 4. I am saying 10 now, which is clearly out of index range. Okay, the index range is 0 to 4, and I'm going 10 position, and I'm say my new fruit. Right. So when we do this, it doesn't throw an error, and we can print my list one more time. So when you print it, Python automatically understands that you're trying to insert this particular element in the last position. Though you pass an index which is beyond the index range, it still puts it in the uh, last index. So if you want to see what is the last index, you can say my list, and our last position is 0, 1, 2, 3, 4, 5. So the last value is 5. If you notice, index value at index value 5, we have our new fruit, right? And then we can, I think so far you have understood we have not done much. We just started with an index. We are looking at we started off with a list and we are looking at indexes, how to use indexes to call out the elements present within the list, and also how to insert elements. So this is called as mutation, where you can modify the existing variable which is of type list, and then you can insert or drop particular elements, right? So if you want to use sort, say this is one more command, sorting of list. Say sorting of list can be done. Say my list dot sort. We can say my sorted list equal to, there is something called as sorted, and then we'll use my list within. So when you type my sorted list, then you will have them in the alphabetical order. All right. And then if you, just in case if you want to reverse it, we could say, see reversing. So this operation is quite simple. Okay, one more thing that I want to show you is, though we sorted and if you notice, like we sorted my list and we kept that variable in a new variable name, which is nothing but my sorted list. So if you are confused about if it would have any effects on my original variable, it would not have any effect. You see, my original variable had elements in this format, like we had apple followed by mango followed by kiwi, but when I sorted them, the sort operation is assigned to a new variable, and the old variable stays in intact. It doesn't have any changes there. Okay. So let us see if we can reverse the elements. Okay. Now for reversing the elements, what we'll see is my sorted list. I would say uh, we can use two columns and then -1. So this would reverse the order in which the elements are present. So if you notice, my new fruit was the last element. When I reverse the elements, I have my new fruit in the first position, and apple, which was there at the first position, went to the last position now. That is how the sorting operation and reversing operation is working. All right. Now we can also add couple of lists. So let us say we have, so let us start with my list again. So my list is having this value. Now let us suppose I have new list and it has got a new fruit called banana and grapes. Now banana and grapes were not part of my previous list. What I'm gonna do is I'm gonna create new list with banana and grapes. Now I will add my list plus new list. Now we can use print command to see what is the output of this. And if you notice, what happened is, because new list was present in the second, was a second variable, all the elements of the second variable got inserted into the last indexes of the variable. Now if you want, you can assign this. Say I could say my list equal to my list plus new list. So if I print my list now, this would give the updated value. So this is how it works. Like whenever you want to add to list, you can always add the list and uh, increase the elements that is present. Okay. Now in the previous step, what we saw was we use something like this columns. So let us see how to access multiple elements within a list. Okay. Now so we'll begin with my list again. Now my list has got all these fruits. Now what I'll do is I want to identify all the values that is present between 0 to say an element of 4. Now the anticipation is because we use index 4, it has to bring all the elements up to 4. It doesn't include 4. So it does something like this. So it includes the first element, but it doesn't include the last element. So you notice, like, maybe if you have no understand this terminology where an included number will begin with a square bracket, but an excluded number will end with an parenthesis. So in this case, I'm starting off with 0, but I'm not going till 4. I'll stop at 3. So 3 will be included. So let us see what is output. And if you notice, we have apple, mango, kiwi, and dragon fruit. All the 4 elements are coming in this list. So similarly, if you want to begin with, say, first element, we can start off like starting with 1. I want to go till 4. So as you might have guessed, it will start from mango and it will go to kiwi fruit, right? So we can play around with this. Let us try what would happen if we don't give the last element. For example, I begin with 1 and I don't give the last element. So it means that we have to start from first fruit, which is mango, and get all the fruits within the list. So if I do that, as you rightly observed, I don't have apple here. See, my actual list contains apple, but because I want to access from the first element, it says it gets all the elements from mango till the last element, till the last fruit, which is grapes. Okay, so similarly, what we can do is we can do it in a reverse way also. So for example, if I want to access everything from the starting, but till fourth element, so it will bring everything from apple, mango, kiwi, and dragon fruit. So this is same result of starting with 0. So if you notice, we started off with 0, we ended till 4. It gave 4 fruits: apple, mango, kiwi, and dragon fruit. Same result we have it without having the starting element. So that is how we can start using the we can slice the indexes by using colon and access more than one element at a time. Okay, so just in case if you want to get all the alternate elements, so let me show my list one more time to you. We have my list like this. Say we want to access all the alternate elements. Okay, so when I say alternate elements, my expectation is that I will get uh, something like, say, apple, then followed by kiwi, then followed by green apple, followed by banana. So for doing that, we can say my list. In this case, we'll have to use two columns and followed by how many steps you want to get. So what it does is it takes first element, skips the second, takes third element, skips the fourth, like that. So let us see how the output comes like. And you see, we started off with first element, apple. We skipped the second element. Then we moved to third element. We skipped the fourth element. Then we moved to green apple. So every alternate element is picked from the list and it is shown in the result. That is how it works. Like if you want to use the alternate elements, you can keep use something like this: a simple double colon and followed by 2. Okay, and in the last class, we also saw something like deep copy and shallow copy. Okay, so like this, if I say uh, my list equal to, say, my list 1 equal to my list. Now, what I'll do is I'll print my list 1 followed by print my list. Okay, whenever you want you're printing like this, it becomes very difficult for us to understand which variable, I mean, what value is coming from which variable. In order to have a clear picture, maybe you can use the variable name itself. So in this case, I'll say my list 1 followed by a comma. Okay, similarly, we can do the same thing here. I'll use double quotes, my list followed by comma. So in this case, it will give you a reference. It says that my list one is so and so and my list is so and so. Now let us see if we modify my list. I'll give some random integer and I'll put some random number here. Okay, if we modify my list, will it affect my list one or not? So I have inserted my list. Now let us print back these two variables, I mean these two lines. As you noticed, though I added one element to my list, I did not make any changes to my list one. But what is happening? The same element is coming into my list one as well. So this is something like two different people looking at the same thing. So the variable, the value which the variable my list was using, it has some address in the memory. So when you said something like this, what has happened is even my list one is also looking at the same memory. So it is like two people looking at the same thing. Now, if you don't want like that, you want two people to look at two different things, then you will have to use something called as copy. So my list two equal to my list dot copy. As simple as that. Now let us see what is the difference between my list two and my list. So we have my list two here, my list two and my list. I'm going to print. So if you notice, as of now, the my list and my list two are both same. Now I'll modify my list by using insert command. I'll give some random index value and I'll say 51, for example. And then I will print the same thing. You see, my list 2 doesn't have 51 now, and my list has got a new element. What has happened in this case is when we said copy, it copied all the elements from memory to a different address. Like let us say we have two bins. Okay, when we have two bins, from bin 1 it copied to bin 2 all the elements with whatever elements and whatever value it had. Everything is brought into a different bin, and the new variable is looking at bin 2. It is no longer looking at bin 1. And when you modified bin 1, bin 2 doesn't know what has happened in bin 1. They are independent. So this is how a shallow copy and deep copy would work. And if you're working into any software development, like it could be data science or it could be web development, I think this would be a basic concept that you would be always keeping in mind. All right, so let us continue now. So far we have seen all the slicing part and all. What I'll do now is I'll use something called as, so because we are already working on lists, I'll try to cover something called as loops over list. So it will be nice if we keep all the uh, Python knowledge in a consolidated way. So whatever is related to this, I think it's better to cover off in the same session. So as of now, I think we covered a lot today based on something to do with indexes, some operations on lists. So we have seen how the insert works, how we can skip couple of elements. Now, before going to loops, let us see something called as removing an element or popping an element. Okay. Now let us say now we have my list. Now I have two elements which do not belong to this cluster. Okay. So we have something called as 50 and 51. Now if I want to remove 50, for example, I could say my list dot remove, simply say the value of the element. Okay. Just keep this in mind. When you're using remove, so when you're using remove, it uses the element itself. So if I do that and I print my list one more time, we don't see 50 here. Okay. if I repeat this operation, probably it can throw an error because that element is not found, See, not in list. So it says that 50 is not in list, so it is throwing an error. The same operation can be done by use of index. Say, for example, we don't know what is the value that is present in so and so index, but we want to remove a particular index from the list. So I have my list now. If I want to remove 51 now, so 0, 1, 2, 3, 4, 5, 6, 7, 8. It is an eighth element. So what I'll do, my list.pop, I'll say 8. Now, if you notice, in the case of pop, because you're using an element, it shows which value got removed from the my list. And in both the cases, we need to remember that we are not assigning it back to the variable. In the case of remove also, we are not assigning it back, and it is automatically assigned. Similarly, in the case of pop also, we don't have to assign it back. It is automatically assigned. So if I see my list, it is already updated, right? So we don't have 50 and 51. This is how the pop and remove would work. So far we have covered something like slicing, followed by pop, followed by remove, and then we followed by insert, and then we have seen something like sort. So these are the basic operations that we could do using a list. Now let us move forward to loops. Now, this is one basic concept that we would be using more or less in any application that we are coming up with. So what I'll do is, for simplicity, let us take a new list. For example, say I have something called as primes. Okay, I have prime numbers 1, 2, 3, 5, 7, say 11, and 13. For example, we have all this. Now, uh, what happens is if we want to iterate over primes. Now, when I say a for loop, it is trying to do a same task, but repeated number of times. So that is how a for loop works. So for example, if I want to repeat a particular operation 5 times, but changing some particular variable. So I'll show you a simple for loop, how it looks like. Say, for example, for I in primes, okay? Sorry, for I in primes, what I'm doing is my simple operation is to print I. Okay. We started off with a simple list. Now, what we're trying to learn here is how does a loop look like? Like if I want to use a for loop on primes, I want to take one element at a time, print it, and then pick the next element, print it, then pick the next element, then print it back. So I will do it as long as the elements exist in the prime in this particular list. So if we run this, you can notice that all the numbers are printed in the sequence. So you started off with 1, it printed, then it took the next value, it printed, then it took the third value, it printed, then the fourth, fifth, sixth, and seventh. So this is how uh, prime work. Now, if you notice, what it is doing is, what we are saying, we are taking I as a variable, and we are saying a variable is having a particular value from the list. Now we can do the same thing in a different way. Now what I'll do is, instead of saying, say, I in prime, I can say range length of prime. Now, what is length of prime? Length of prime, sorry, length of primes is 7. Now, what is range? So it is 0 to 7, meaning 0, 1, 2, 3, so on up to 6. 7 will not be included. As I told, like this is the excluded value, but till 6 it will perform. So same value, what we are doing is we are iterating the index. Now, previously we iterated with an element. We took one element at a time. But in this case, as you notice, this is 0, 1, 2, 3, 4, 5, 6. So these are indexes. So what I'll do is, instead of saying print I, I'll say print I, comma, uh, primes, if you remember, if you want to call out a particular item within a list, you have to use the index value within a square bracket. So this is my variable. I'm calling out a particular index within that variable. So if you do it, you'll notice at 0th index. So I'll just show you primes one more time. So at 0th index, we have 1. First index, we have 2. Second index, we have 3. Third index, we have 5, and so on up to 13. So that is how we can loop over a list, either by picking up the element itself or by picking the index of the element. In both ways, we can do it. All right. Now, as you move forward in the career, for loops are very good. Okay. If as long as it is not time consuming, it is very good. But uh, as the size of the list increases, what happens is this for loop can become expensive, meaning it can take more amount of time to complete the operation. So in that case, what we do is there are a couple of cases where we go for list comprehension. So list comprehension is something which is a similar activity of for loop, but in a different way. So for example, I want to get all the elements which are present in primes. Okay, but I want to assign it to a different value. Say new primes equal to so, something like this, because I want the new primes to be also a list. I'll say it's an empty list. Now what I'll do is x equal to x for x in primes. Now previously what has happened, if you saw this for I in primes, what did it do? It picked each element one at a time. Okay. Similarly here also what it is saying is, look at the second part of the statement. It says each element of the list. Now what we are doing, we are simply storing it. Now this is something like expression. Now if you notice, let me write it down. So we have expression followed by for element in list. Now this expression can take list as an input. Expression can take element as an input. Say for example, I'll say element. Now in this case, what I'm doing, I'm not doing anything. I'm just simply storing it. So let us see print new primes. Now if you notice, I have the same value. Okay. Now what if you want to double the values? So I'll say x into 2. So simply whatever value that I have in primes, I want every value to be multiplied by 2 and stored in new primes. So for that, what I'm doing, I have an expression which says multiply the item into 2 and take one element from prime at a time. So I'll take 1, multiply with 2, store it in primes. Then I'll take 2, multiply with 2, put it in new primes. Similar like this. So if we rerun this, see every element got multiplied by 2. So if you want to achieve this, we can achieve the same thing by for loop. So for example, I'll say new primes 1 equal to empty list. Okay. For example, if I want to use by for loop, so for I in primes, I will say new primes. If you notice, we have used append in the last session. So we are appending I into 2. Notice in append also, we don't have to reassign to the variable. It will be it will get updated automatically. So I'll print new prime 1. So in this case also, by using for loop also, we can achieve the same thing. But only thing is that as you move forward, like this is a better way to write the expression than use the for loop. But as an based on the needs, right? Not everything can be achieved by your list comprehension. So in couple of cases, if list comprehension is not possible, then probably you have to go to for loops. So this is how we can use multiple operation on list. Okay, so now let us take two different list. Okay, So I have list one. In list one, I have continuous numbers. Say I have 10 values. In list two, I have couple of values like all even numbers, 4, 6, 8, 10, 12. For example, like this. Suppose you have two lists like this, list one and list two. And our intent here is to find common items. Okay, there are multiple ways to do it. The best way could be, again, use list comprehension, or maybe convert them into sets and use an intersection and put them back into a list. But anyways, like now, because we are discussing about list comprehension, let us see how we can do it. So I'll say common items equal to x for x in list one if x in list two. So we have two different lists. Our intent here is to find out whichever element that is common to both of the lists to be present in a new list. So what I'm doing, I'm picking one element from list one. I'm checking if the element is present in list two or not. So x for x in list one, if x in list two. So I pick one, I check for one in list two. I don't find it, so I ignore it. I pick two, I find it in list two, so I keep it. I store it. Okay. Then I pick four, it is found. I pick six, it is found. I pick eight, it is found. I pick 10, it is found. Okay. Let us see now what the output looks like. Now this is how the output looked like. It has bought all the common items within two different lists. All right. Now on the same context, like if we want to uh, make tuples out of it. For example, I want to make tuple. Uh, if you remember tuples, right? They are non-mutable elements. It's same like list, but they are not mutable. So what I want to do is I want to create tuples out of both these lists. Like how to create, like if you know something like Cartesian product, I want to pick one element. I'll create a tuple with every element of list two. So one, two. So the tuples will look like this: 1, comma 2, followed by 2, comma, sorry, followed by 1, comma 4, followed by 1, comma 6, followed by 1, comma 8, followed by 1, comma 10, followed by 1, comma 12. And then again, I'll pick the second element. I'll say 2, comma 2, 2, comma 4, 2, comma 6, and so on. Now, let us say if you want to do this, how would you do it using list comprehension? Now, I hope you understood what we are talking about. So don't worry about it if you do not understand. It's not so important, but just to understand, just to make you uh, understand about this list comprehensions, how to use them, I'm just going to show you how to do it. Okay. Now it is same like this. Now whichever expression that we have to put, so we'll say x comma y. Because I want to use two different elements, I'll say x comma 5 for x in list 1, for y in list 2. See, previously we had a if condition, but in this case, both are for. For every x in list 1, create a tuple with every y in list 2. That is what it says. For every element in list 1, create a tuple with every element in list 2. So if you run this, see, we created the same output. With one of first element of first list, it created tuple with all the elements present in list 2. Then it started with 2. So that is how we could use two different lists and still work with comprehensions. So we don't have to use double for loop. So if you keep on using for loop within for loop, right, it's gonna take more and more amount of time. So that is how we can. I think that is all about lists today. I hope it was helpful for you. I think in the next section we can get started with tuples. Thank you so much.